Hello and welcome to another tutorial. In this tutorial I'm going to discuss a very nice way to turn your Java code into a graphical interface that you or any other user can interact with, and this is specifically for Java codes that are dealing with numerical evaluations. They take some numbers and create some numerical results, and this is a very great way that you can effortlessly transform your Java code without any extra code into a graphical interface. So this is based on a project on my GitHub. It's called Javanco, and basically the goal here is that if we give you a Java class, we want to create a graphical interface for it. And the graphical interface basically represents the constructor of this Java class. So represents the constructor of Java class. All right, and then the user can basically interact with the parameters in the constructor and populates them. So and this graphical interface, or basically this project Javanco, allows to iterate over the parameters of the constructor. The user can input different parameters. You can use some of the calculations that happen in the class, right? You can access the method of the class and do the calculations and add the results to a data collector. And eventually, after doing the calculations, you can present all the results using a result manager with plotting capability, or basically it has nice visualization tools. So visualization. So this is especially useful for math projects when you're doing numerical calculations. And if you go to my GitHub, github.com/Java Novice Programmer, and then you search for Javanco, you can find it. You can download it or copy the link and import it in Eclipse. All right. After you do that, now you have the Javanco project ready to go. So how does as I mentioned, you go to GitHub, you get the link for Javanco, you import it in Eclipse, and this Javanco, in order to create a graphical representation of the constructor of any Java object, Java class, it works based on the reflections framework in Java. If you're familiar with reflections, you know that it just loads the metadata or meta information of a class object. For example, the type of parameters in the constructor, the type of methods, and everything. Okay, so you can when you run the GUI, it loads all the classes that are involved in your class object, and then loads all the information all the information from them and puts them on the graphical interface for the user to interact with. Okay, and eventually it creates a tree view of your Java code, and this tree view is based on Swing Java library. It's a Swing application. And how do we use this? So if you create a class, for example, let's say you have a function, and if you recall, when, for example, we developed our symbolic math functions, we defined a top level abstract function. So the top level function, the general function, was an abstract class. And when you put an abstract class as the argument of a constructor, the Javanco basically searches for all the subtypes. For example, we then developed sine of x, cosine of x as concrete implementation of this abstract function. So Javanco is easily able to load all the subtypes of a specific object that you put in the constructor as a parameter, and gives them as options to the user. So user can choose, for example, here sine, cosine, or any subtype of the abstract class. All right. So all of these are handled in the background by the GUI, by this project. And so one of the use cases that I'm going to discuss here is just trying to evaluate different functions in a very easy and nice way. And one way is to use abstract classes as the parameters, and the Javanco automatically searches for all the subtypes of this abstract class. All right. And then in order to run the graphical interface, you have to, your Java class, eventually the Java class that you write to run your application has to implement an interface in this javanco project. It's called experiment. And this experiment adds a run method. So it adds a run method to your code when you implement it. It only has one method, which is called run. So in the run method, you create a data point, all right? And in the data point, you add your parameters, the name of the parameters that you want to add to the database or the data collector. And then, so we have a data collector and the result manager that basically interacts with the data collector. So your run method is basically data collector. And here in the data collector, you create the data point, and each data point gets a string value and a double or boolean or any type of primitive type. So you, in order to save a variable, a parameter to the database, you have to specify its name as a string, and then its value. It could be a boolean value, a double value, a float, or int, doesn't matter. And then also, if you plan to do a 2D plot, you have to specify whether the parameters that you're adding to the data point is supposed to go on the horizontal axis or the vertical axis. And in order to do that, you can use one of these two methods. One is add property, which adds a property as the x parameter, horizontal axis, or add result property. Result property means it's a result of calculation and it should go on the y-axis, all right? So here's an overview of the javanco project. It has two top-level packages. One is general libraries, so you don't need to worry about those. But there is another one which is called javanco X or javanco execution. This is where all the stuff happens in terms of loading the GUI and doing the data collection and visualization. So general libraries takes care of the class loading and this kind of stuff. In the javanco, we have the experiments package and the result manager. Now experiment basically builds the experiment, and the main class is this one, experiment configuration cockpit. This one, you basically can specify which class to load or which classes to load from which packages, so you can limit the visibility of the packages and classes, all right? And I'll have an example to show how this works. And the experiment builder or the builder package takes care of class loading, takes care of object enumeration if you have multiple combination of the objects, and it also implements multi-thread capability, which can significantly speed up your calculation process. So this is a very nice advantage or a plus for this project. And then we have the result manager, which takes care of data collection and visualization. And in the heart of this result manager is the smart data point collector. This is where you add the data, the results of calculations, and it has a nice filtering capability. And this result manager also takes care of displaying and plotting. So we have this display package, the GUI package, all right? And then also takes care of filtering data, and the filtering of data happens in multiple places, especially in the smart data point collector, all right? So smart data point collector is the heart of result manager. Now here's an example that I have here. So let's say we want to use our symbolic math project that we developed and try to plot some of these symbolic functions, all right? So I create a class called test javanco. And this class, in order to be able to run it and create the graphical interface, I have to implement the experiment, all right? So I must implement the experiment interface to use the run method. So when you implement the experiment, it adds this run method, and the run method has two parameters, abstract result manager and abstract result displayer. And typically we only interact with the manager, and the manager just when you create your data points and add your parameters and their values, eventually you add the data point to the manager, all right? So what do I need to do here after implementing the experiment? I define two global variables in this object. One is the function, and one is the double for the value of the parameter of the function. All right, so basically I want to evaluate the function at some value, and I have to, in the constructor, in order for the user to be able to interact with this class, I have to let the user choose which function and what values. All right, so the constructor of this object should have two parameters. One is the object class, which is a function, and if you recall, this was an abstract class, and a primitive type of double value, and then I assign them to my global parameters here. All right, so this constructor is for testing our symbolic function class, and when you run the javanco and it creates the GUI, it basically represents to the user this constructor. All right, and if you notice, I have an annotation here for each of the parameters in this constructor at param name. This param name, this annotation is for the javanco, and this takes a parameter called name, and you can also specify default values in the GUI. All right, so I typically use the name value. If you don't want to have a default value, you can just use the name parameter, and in the name parameter, basically the name parameter adds this string representation or description to the GUI when you create the GUI, and I'll show you in the next few slides what it means. All right, if you don't do this, the GUI just creates a box for this parameter, for example value, without any description, so the user might not know what this parameter exactly is. Okay, so it's better to have this annotation for all the parameters in your constructor. All right, so the constructor is very simple, and this is where the GUI, this is the entry point of the GUI, right? If you recall, function is abstract, and I told you that javanco automatically takes care of loading all the subtypes of any object that you put here. So when we create the GUI and run it, the user can actually choose any number of functions, a concrete implementation, sine, cosine, or whatever. All right, so having an abstract class as a top level entry point in the parameters of the constructor is a benefit, because all the subtypes or the children of this class are also automatically loaded and presented as options. All right, so in the run method, it's very simple. I create a data point, all right, with no argument parameters in the constructor, and then I want to have the value that I put here as the x-axis, so I name it x and add the value, and it's a property, okay, which goes, as I mentioned before, add property puts this parameter on the horizontal axis with this name. And then we also have another one, add result property, which typically is used when we're adding some results of calculations. And when you use the add result property, it puts this value and assign this name to this value and puts it on the y-axis. All right, so here I'm as the name, so the value of this result property is the value of the function, which is I'm using the get value method for our symbolic function and evaluate the function at the given value. And then for the name of this variable, I use function semicolon space and then get the name of the function, func.toString. All right, so I add these two to the data point, and then I add the data point to the manager, result manager. All right, so this is how you implement your experiment to create the graphical interface, but then you have to call the experiment configuration class and execute it to be able to actually run this class. And when you want to run a class, you use the main method, right? So I have the public static void main, and here I'm calling the experiment configuration cockpit. All right, and in the experiment configuration, I call the .execute, the execute method, and it takes two arguments. The second one is a boolean that says that if basically when the user closes the window, what happens? Should JVM terminate or not? So I set it to true. So if I hit the close button, for example, in the close button of the window like here, it's going to terminate the JVM. The first one is called arguments, and that basically tells the javanco when it tries to load the classes, which class to load what is the entry point of the class, what is the top level class that is going to be loaded, and here I'm using this one. So I want to basically run the constructor of this class, test javanco, as the top point or the entry point of the GUI. So I say, okay, my class name is test javanco.class get name. All right, this is the top level, and from here it loads creates a GUI for the constructor of this class and loads all the subtypes of all the parameters of this constructor. Okay, and then the package name is which packages to look into. Here I just put it at as the top project Symbolic Math. I want to be able to load all the functions in the Symbolic Math class. You can have multiple packages and you can just differentiate them with a semicolon. All right, these are typical VM argument or JVM argument. All right, and then you have to create an array of strings with the -c and -p identifiers. So -c class name, -p package name, and then you pass them to the to this execute. All right, so this is how you test this javanco class and create a graphical interface for this javanco class, because we're setting the class name, the entry point of the javanco as the constructor of this class. All right, now when you run it and it generates the GUI, you see that it starts with the test javanco class. So the entry point is the test javanco, and it loads the constructor of this test javanco, and it tells the user, okay, this constructor takes an object of type function and a primitive double. All right, and if you recall, these two annotations we added, for the function we added the annotation of choose function, for the double we added the annotation of value. Right, so this annotation, choose function and value. So that's the good thing, because then the user understands what's going on, what each of these boxes is about. So the first one is choose function, the second one value. And when you put any primitive type, the GUI automatically creates this box and adds this add button next to it. For example, for a double value or a float, you have this put your value here, and then you can put as many values as you want, doesn't matter. And then in the choose function, because this is an abstract, so by default it doesn't have any implementation, but it has some subtypes or children that have concrete implementations. So in order to choose them, the user can just right click on this box, choose function, and select as many functions as he wants. And if you recall, our symbolic functions had two constructors. One was empty constructor and one was with the another function. So this way, if I choose just cosine of x, it means I'm choosing the constructor with no function as parameter. So it's just cosine of x. But if I choose, for example, ABS of a function, it automatically loads all the subtypes of the arguments in the constructor. So again, you can choose any function as the argument for the constructor of ABS. So here I'm choosing cosine. So basically what happens here, I'm plotting two functions simultaneously. One is the cosine of x and the other one is the ABS of cosine of x. All right, and for some values. And here in the GUI we also have a few buttons here. Save. If you press save, it just saves this tree configuration, all the configurations, into a default file which is called tree on desktop. So the default save path is desktop. If you choose save as, it just opens a J file chooser, and then you can set a path and set a name for the configuration that you want to save and save it at a given path. All right, so these two save the configuration of the tree into a file. All right, so this one, and then finally when we execute it, when we run the configuration tree, we get the result manager. So it does all the calculations and creates this visualization. You have the capability to plot the results. Here are the results. We have cosine of x and absolute ABS of cosine of x, and then in the x-axis I'm selecting the x variable that we put in. You can have multiple variables, and you can plot based on any variable that you put on the x-axis. And then we have plot filters here that currently I'm just selecting constant, so there is no differentiation between the data points on this plot. They all belong to the same plot. And then we also have besides the plot filters, we also have data filters. So here, if you go there, you can choose from all these values of x, you can select just a couple of them, and then it plots this function based on just those specific values for x. All right, so sometimes you want to, if you have multiple parameters that are on the x-axis and you want to filter only a few of them and plot a filtered result, then you can go to the filter and select them. Okay, so let's head to Eclipse and try to have a closer look at the code. So if I go to Eclipse, I have already imported the javanco project from GitHub. If you don't know how to do it, you can just go to the GitHub, copy the link, and then go to the files here and select import. And in the import, you just select from the Git project from Git. All right. And here, instead of having a local repository, you clone the URI. All right. And it automatically imports it. So here I'm going to disconnect this from the GitHub because I'm not going to commit anything. So it's disconnected. And in the source, we have two top packages, general libraries, that takes care of loading the classes. And then we also have javanco execution, javanco X, which has the experiment builder. So the main class here is the experiment configuration that basically has the execute method, and it runs the GUI. And then we also have result manager, which has the display GUI packages. And then we also have the smart data point collector here, which is the main class that deals with data and how to arrange them, how to plot them, etc. All right. Now then, if you recall, we had this Symbolic Math project, and in the Symbolic Math we had two packages. One is Symbolic Math, implements some elementary functions, and the top level function is an abstract class function, and also it implements the operator overloading. Okay. And we had different functions, cosine for example, and each of these concrete implementations of the function have two constructors. One is a no-R constructor, which the composite function is null, which means if I choose this one, it's just the cosine of x, cosine of my variable. If I choose the composite constructor, it's the cosine of the function inside. All right. And obviously for the get value method for each of these, we checked whether or not the composite function is null. And also we can calculate the diff based on the chain rule. And we also have the toString method based on testing whether or not the composite function is null. All right. So here in the test package, I have created a test javanco class, and I'm implementing the experiment. When I implement the experiment, it automatically adds this run method, and in the run method, I'm creating a data point. I'm adding the variable that I want to go on the horizontal axis. I label it x, and the value is just the value that the user puts in to calculate the function at that value. And then result property is the result of calculation, which goes on the y-axis. I call it function colon space func to a string, so it adds the name of the function and then evaluates the function at the given value. And after adding these two to my data point, I add the data point to the result manager. All right, this result manager. So don't forget to add this data point to the result manager. All right. Now after doing that, I want to run this class. So in order to do that, I have to specify for the experiment configuration cockpit, I have to call the execute method from the configuration class, experiment configuration class. And then I want to tell it that, okay, when you execute it, use the constructor of this class, test javanco, as the entry point of the GUI. Okay, because the GUI creates a tree, and the tree has an entry point, the top level class. So I want to specify this class, test javanco, the constructor of this class, as the entry point. So in order to do that, I create a string called class name, and I get the name of this class. So test javanco dot class get name. All right. And then I know that all of my functions are in the symbolic math package. So what I tell the javanco to do, I set the package name and tell, okay, only look into this package, symbolic math, because all of my functions are here in the symbolic math package. I could have, for example, symbolic math and for example, tests packages. So, but I'm not using any of these classes in this package. So none of these classes in the test package is the parameter of the constructor. So it doesn't matter if I add this to the path or not. Right now I'm just keeping it at the symbolic math, okay? Because all of my functions are in this package, all right? Because you have to specify where, for javanco, you have to specify which packages to look into when it's trying to find all the subtypes of these functions or these parameters of the constructor. Okay, so I have the class name, package name. I put them as a string array, and you have to specify the type of arguments. One is -c, which means it's the this is the class name, and -p, which means these are the packages that you should look into. And then execute method has the string args, and then boolean system exit. System exit means if it's true, when the user closes the window, it terminates the JVM, which is what we want here, all right? And as I mentioned, I'm using this annotation at param name, and you can have name. So if you look at this param name, it's in the javanco. It has name, default, underscore, this is a method, default class. So you can, if you have a primitive type and you want to set a default value for it, you can use the default underscore. If it's a class object and you want to specify a default class object for this parameter, you can use the default class underscore. Okay, and these annotations are very useful for the user because these are the descriptions of these parameters in the GUI. So let's run this. So when you run it, what happens is that it says creation of the class repository. So it goes into this symbolic math. So it loads the constructor of that you specify as the entry point, and then it goes into the parameters of the constructor, finds all the, looks into all these packages that you specify here, and tries to find all the subtypes of the objects in the constructor here and loads all of them. Okay, so it creates a class repository and loading initial interface, which is this one, and it gives you 4 options. One is create a new GUI, load from default file, which is on the desktop, load from a file which you have already saved somewhere, and run default file. So here it just looks into the desktop as the default path, tries to find a default configuration file which is called tree, and then runs it, so you don't need to recreate the GUI again. So I'm just here going to create a new GUI. So this graphical interface is a tree. So we have these 3 buttons, save, save as, and deploy tree. We have the run button and it says not ready. We have clear database, clear cache, and load tree. Okay, and we also have here in this box the number of threads to use. I'm going to use 4 threads. And as I mentioned, if when we specify a class name as the test javanco, this means the top level entry point of this GUI, the tree, is the constructor of this object, test javanco. So in order to load the parameters, I right click on this and it tells me, okay, there is only one constructor in this class which has 2 parameters. The description of the first one is choose function. The description of the second one is value. These are the annotations that we put here. All right, so I click it, I select it. It has 2 annotated boxes. One is choose function, one is value, and it also shows the qualification or the qualification of the constructor. It says that, okay, test javanco class, you chose this constructor and it takes an object of type function and a primitive type double. And this function, the description is this one, choose function, and this double, the description is value. All right. So if I want to choose one of these abstract, one of the concrete implementation of the function, you can right click on it and it automatically loads all the subtypes in the symbolic math package that we already specified here. So we told it, okay, look into this package to load all the classes you need. So it says, okay, there is an ABS class of type function in the symbolic math package, AX, cosine, cotangent, delta, X, FC, constant function, log, log10. And it also loads all the constructors for each of these classes. For example, if I choose cosine, it tells me that it has two constructors. One is cosine with empty arg or no arg. One is a cosine with a function as an argument. And it also gives me two options, void, default. So I didn't specify any default values for any of these arguments. So if I choose default, the void and default are basically the same thing here. But if I set some default values in the constructors for any of these parameters, then when I load default, it automatically loads the constructors that with the default values. So here let's use cosine with empty and use void. So it creates a node in the tree which is called cosine. So this means that right now this constructor test javanco class is getting constructed with the object type function of type cosine. All right, the function object is being cosine, and there is only one instance. The user has chosen one. Now I can choose another function too. So if let's say I want to also plot cosine and cosine of a function or another function. Let's choose ABS. Let's say I want to plot the absolute value of the cosine. So I choose ABS, but instead of empty constructor, I choose ABS with a constructor that takes another function. And let's choose the void. So here, and as you can see, whenever there is something not completed, it's shown by a red color. Whenever something is completed, it's shown by a green color. And you can only run the GUI when all these boxes are green, and this text then changes from not ready to ready. So I added another function, ABS of a function, and again it looks at the constructor of this class, ABS function, and loads all the subtypes of the parameters in this constructor, which are all the functions. So cosine with empty. So what happens here, I'm plotting two functions, cosine, ABS of a function, which is cosine. So cosine, ABS of cosine. All right. And now I have to specify the values, and the notation here is that you can use something similar to this MATLAB when you use lean space. So I want to say minus 3 pi colon 3 pi, and you can use lean or log. I'm going to say it's a linear spacing between the points, LIN, linear, and I want to have 1000 points and add. So it automatically creates minus 3 pi to 3 pi on a linear spacing between points. All right, I have 1000 points, 2 instances of the function. So in total we have 2000 cases to evaluate. For each function, 1000 cases. So I'm using 4 threads. Tree is ready for 2000 experiments. Let's clear the cache and database and run it. All right. So it runs 2000 experiments in parallel with 4 threads, and it took about 164 milliseconds. Now eventually we get to this result manager. So on the y-axis, whatever we added as a result property or y-axis property, it goes here. Whatever we gave as the property or x-axis property, it goes here. So I want to plot x, I want to plot cosine, and the plot filters are constant. So I just want to plot everything from x for this plot. All right. So this is the cosine, and this is just the JFree chart. So we have the standard JFree chart configurations. We can increase the font size for the x-axis. We can increase the font size for the y-axis. All right. You can zoom, you can save it as a PNG, you can print it. So this is the standard jfree chart. And now I can plot the other function, which is the absolute value of cosine. All right. And again, I achieve this absolute value of cosine by calling the ABS, the constructor of the ABS class that accepts another function, and the GUI automatically loaded all the functions that I could pass, which is again all the functions, all the classes in the sim_math package. All right. And we have 1000 values. And I can also plot both of them on the same axis. So cosine, so this is cosine, this is the ABS of cosine. But now the problem here is that there is no way to differentiate the color of the two, or the two plots here. This is one of the limitations. And typically what I do is I use a plot filter here. And in order to do that, I have to have the same Y label for both of these. So let's save this on the desktop as a default file. Let's go back to the code. What I'm going to do here, or what I'm going to try to do, instead of having this line, I'm gonna have it as the same name, just function. All right. I don't want to differentiate the Y properties or the values that go on the Y axis based on the name. So all of them have the same name, but different values. So whatever function or multiple functions that the user puts, they will get saved in this function variable. And then I'm going to add a DP, add property, a string name, a string value, and I'm going to say function. All right, or the name of the function name. And here I'm going to call the func get or to a string. Okay, so this is one of the plot filtering functionalities, and let's run this again to see if this works. I'm going to load from the default file and clear everything. As you can see, all the configurations are still there. Let's run this. And now on the y-axis I only have function, one variable instead of two. So I put x here, but now in the plot filters, instead of constant, in the constant, what it does, it takes the mean value of the cosine and ABS of cosine. If I select no lines, you see that it automatically has two functions there. But the default property is to have the average of the two. But instead of doing this, I'm going to select the plot filter called name. And if I enable the legend, now you see that I have one y variable which actually contains the values of two functions, and I'm differentiating them based on the filtering here, name. And the legend says name cosine is the red color, name absolute value of the cosine is the blue color. All right. Now if some data points have the same values, it uses different markers, so we can say without highlights. So all of the markers are just squares. So if I remove this, it uses different markers. If I enable this, all the markers are basically squares. Okay, so this is how you can differentiate different plots. So instead of having multiple y variables, I have one variable, but I use this box as the plot filtering. Okay, and that's how it works. And then we can see different colors and different styles, and you can also have the legend. And so this is there are other things that you can do with this graphical interface, but it's extremely useful, as I mentioned before, for numerical evaluations. Whatever you have, whatever Java objects you have that you want to use to create some numeric results, you can use this graphical interface. And the other nice thing is that if you run this, and then let's load from the default file, and let's say we create this application, right? So basically this class right now is an application, right? And the user can choose any function and plot anything. So if I right click on this class that has the execution of the cockpit and say export as a runnable jar, and let's select the object, select the test javanco as the main launch configuration, The save path is desktop test.jar. What I'm going to do, I'm going to export this as a jar, a runnable jar file. And I'm going to package all the required libraries into the jar, and let's hit finish. Now typically it says that there are some warnings and errors, but it doesn't matter. It is able to actually export it into a runnable jar. And now I have a test jar here, and I have a fully runnable configuration, fully runnable Java applications based on this class. And I really didn't do any coding for my swing interface. Javanco automatically took care of everything. Now I can now I ran this application. I can load from my default file, which is already on the desktop, or I can create a new tree. Okay, let's load the tree again. Load from the default file. Let's use 5 parallel runners. And then here's again the application works fine. All right, so you can use javanco to immediately create an application from your Java file and be able to share it with others. They can run it, plot the stuff, filter some data in the filters tab. I can filter only based on the name of the plot, so cosine or absolute value of cosine, or both of them. Okay, or I can filter the data based on the sum of the values of the x-axis. Let's say I don't want to plot all the 1000 points, so I can only choose, for example, this part, 3, 4, 5, 6. You see, I'm only choosing some of the data points, and it only plots those data points, right? I hope you enjoyed this video. This is a very useful tool in terms of visualizing your Java classes, and I highly recommend to play with this. Try to maybe modify the codes, download it, modify, make it better, and if you make it better, make it look nicer, let me know, and we can add the modifications to GitHub for others to use. Thank you for watching, and I'll see you in the next video.